Today's video will explain the delegate design pattern. Hello, I'm James Helfrich. Sometimes we don't want to pass information between two components, but rather want to pass a command between two components. The simplest way to do this is the delegate design pattern. This video will explain the delegate design pattern, as well as show how to implement it in code. Delegate invocation is the process of passing a function to another component, which will execute the function at the appointed time in the appointed context. These functions are called delegates. Now, from a functional programming point of view, this is called a high-order function. In other words, we're passing a pointer to a function as a parameter. We're going to start with the commander, and this is the component that's going to want the action to be carried out. And we have the executor, and the executor is going to carry out the action. Now, we're going to have a connection between these two, and this connection is going to have a callback as an order. In other words, the order that the commander is going to send to the executor is a function, and that function is called a callback or a delegate. Now notice that the commander could have lots of different components within it, each of which talking to the executor through the same shared interface. There are 4 invocation strategies. The first one is the commander context. In other words, when we send an order to the executor, we send the order as well as an instance of the commander, and so that instance will be used by the executor. The second is the executor context. When we send an order to the executor then sends itself as a parameter in the order. The third is queuing. In this case, the executor will collect many instances of orders and execute them at the correct time and place. And the final is redo. This allows the executor to carry out an operation more than once as the situation requires. Let's take a look at each of these in turn. Now, first of all is the commander context. Here we have the commander, and it's a function or method in some class or standalone function, and it's going to send an order to the executor. But it's not only going to send the order, it's also going to send an instance of itself, and that's going to be used by the order itself. Now, the executor at some appointed time is then going to execute the order. And what's it going to send as a parameter? The executor instance itself. So let's take a look at a pseudocode for the executor. It's going to take an order from the commander as well as an instance of the commander itself, and at the appropriate time and place, it will actually execute that order on behalf of the commander. But that order is going to need some context. It's going to need some parameters. It's going to need to do something to something, and that something is the commander, and that comes in as a parameter. A second example is the executor sends its own context. So we have the commander, once again, sending an order to the executor, but it's only going to be the order this time. There's going to be no data involved. Now, when the executor executes the order, it's going to send itself as a parameter. So looking at the pseudocode, we're going to see that when executor instantiates the order method, it's going to pass itself as a parameter, and that is the context which it's going to operate on. The third one is queuing. Here we're not going to use a structure chart, but we're going to have some pseudocode. The executor is going to be a class this time, and it's going to have an accept order method. And it'll take that order and stick it into a queue. Now, at some appointed time, it's going to execute all the orders in its queue. So it's going to iterate through the queue. It's going to find the top one. It's going to execute that order and then remove it off the stack. And this allows for asynchronous execution of orders. The final example is redo. So once again, we'll have some pseudocode here. In this case, the executor wants to execute the order 5 times. Even though only one instance of the order was sent, the executor gets to decide how many instances are executed. So for an example, let's say we have a video game involving a ship moving through a maze. The ship can speed up, slow down, turn right, turn left, and all kinds of other things. Would the delegate be useful here? I think so. The game is going to send an order to the executor. It's going to say, hey, ship, I want you to turn right, turn left, move up and down. Now the ship's execute function will execute the order, but it's going to send itself as a context. So for an example, in C++, I have several different functions: accelerate, decelerate, turn right, and turn left. And these will all modify the position and the velocity of the ship. On the right here, we're going to have the game, which is the commander, and the commander is going to say, hey, ship, I want you to execute left, right, turn right, accelerate, decelerate. And the executor will then execute that at the appropriate time or place. All right, let's take a look at a couple examples of delegates. The first, I have a function in JavaScript called copy to clipboard, and I take an ID as a parameter, and I'm going to take whatever text is in the tag corresponding to that ID, and I'm going to stick into the clipboard. And then in my code, I'm going to have copy to clipboard, and I'm going to pass D as my tag, and here's my tag, and here's the text that I'm going to copy to the clipboard. So who's the commander? It's going to be this HTML page. Who's the executor? It's going to be, well, whatever browser I have. What's going to be the command? The command is going to be the function copy to clipboard. And what context am I taking? Well, I'm taking the commander's context. The commander is specifying, in this case, the ID that's going to be utilized. Okay, here's a second example. In this case, I want to play a game using OpenGL. So what I'm going to do is I'm going to call UI.run, and I'm going to pass the callback with OpenGL will call 30 times a second. And I'm also going to pass my game state in the object called game. So when the callback gets called, then I have a void pointer because OpenGL knows nothing about my game. I got to cast it into my simulator, and then, of course, display and handle all the input and stuff like that. And the commander is game, which is going to send the callback to OpenGL. The executor is OpenGL, which will execute my function callback 30 times a second. And of course, callback is going to be my order. This is an example of the commander context. Our third example is the priority queue in the C++ standard template library. Now, notice I have a template, which is the kind of data that I want to store in the priority queue. I have the underlying container, in this case, a vector. I also have the lesson operator. And this function will tell which of two elements, in this case, t's, are less than the other so we can order them properly. Now observe the priority queue takes the compare function as a parameter here and then store it as a member variable, and then we'll execute it periodically. Now, in order to call this function, I'm going to instantiate a priority queue object, and I'm going to pass, in this case, the less than spy as the comparison operator, but it could be greater than, and things will be the opposite order. So in this case, who's the commander? Well, it's the person instantiate the object. Who's the executor? In this case, it's the priority queue class itself. And what is the order? The order is the spy function pointer. You can learn more about delegate invocation in the delegate invocation section of the command passing chapter of the software design textbook.